Have you ever just stopped and wondered why your phone can figure out some stuff in like a split second, but other things that sound pretty similar, they're basically impossible for even the world's biggest supercomputers? Well, today we're going to crack that whole mystery open. And we're not going to do it with a bunch of crazy math, but with a simple idea: treasure hunting. Okay, let's get into it. So this right here, this is the heart of the whole thing. Your phone finding a route from A to B, that's one kind of problem. But a company like UPS or Amazon trying to find the absolute single most efficient route for a fleet of trucks hitting thousands of different stops, whoa, that is a completely different animal. And understanding that difference, that's the key to one of the biggest ideas in all of computing. So let's imagine we're going on two different kinds of treasure hunts. First up, you've got an easy quest. For this one, you get a perfect, crystal clear map. X marks the spot, you just follow the instructions. Simple. But then there's the hard quest. For this, we drop you on a massive, mysterious island covered in fog. You know there's treasure somewhere, but you've got no map. All you have is a pickaxe and, well, pretty much endless places to start digging. Okay, so in the world of computer science, those easy quests, the ones with the perfect map, they belong to a group of problems called Class P. The P just means that the time it takes to find the treasure grows in a nice, predictable way. You know, if the map gets twice as big, it takes you about twice as long. No surprises. Things like sorting a list of numbers or finding the shortest path between two specific points, that's all Class P. All right, but what about those hard quests on that foggy island? Well, those belong to a group called Class NP. And here's the fascinating twist. Finding the treasure all by yourself seems completely hopeless, right? But what if a friend pops out of the fog, points to a random spot and says, "Hey, I'm pretty sure the treasure is right here." Well, you can check their answer really fast. You just dig in that one spot. So that's the key. Finding the solution is incredibly hard, but verifying if a solution is correct, that's easy. So what do these hard quests actually look like in the real world? Well, the famous traveling salesperson problem is all about finding that single, shortest route that hits every single city on your list just once. The knapsack problem, that's like trying to pack a delivery truck with the most valuable combination of packages possible without going over the weight limit. And the clique problem, that's like trying to find the biggest group of people on a social network where every single person in that group is friends with every single other person. Now, all these hard quests, they seem totally separate, right? Different challenges, different rules. But computer scientists discovered something absolutely amazing, a deep, almost magical connection that ties so many of them together. They found out that some of these quests are universal. These really special problems are called NP-complete. You can think of them as the legendary master quests on our mysterious island. And here's the part that will blow your mind. If you could somehow find a secret, fast map for just one of them, you could use that map to solve every other hard quest on the island. It's a solve one, solve them all kind of deal. It's wild. So how is that even possible? It all comes down to a brilliant trick called reduction, which is basically like a magic translator. You can take the rules of one hard problem, say finding that big group of friends, and you feed its rules into this translator. It then cleverly rephrases your problem as a totally different one, like the traveling salesperson quest. So if you solve that new quest, the answer can be translated right back to solve your original problem. It's an incredible hack. To this day, nobody has found a fast secret map for any of these master quests. The only way we know to guarantee a perfect answer is the brute force method. Just try every single possibility. So, what does that actually mean? How long would it take a supercomputer to just try everything? Okay, just look at this table. This is where things get completely insane. With 10 landmarks, a supercomputer solves it in 4 milliseconds, no problem. But double that to 20 landmarks, and it jumps to 77 years. Then look at 30 landmarks. It's 8.5 quadrillion years. That is more than 600,000 times the age of the entire universe. This isn't just getting a little bit slower. This is like hitting a brick wall made of eternity. This is what intractable really means. And let's just... look at the number for 50 landmarks. A number this big isn't really time anymore. It's just a mathematical way of saying never. It's not just that it would take too long, it's that it's physically impossible in our universe. The perfect treasure, for all intents and purposes, is simply unreachable. So, what do? We have all these super important problems in medicine, logistics, finance, that we can't solve perfectly. Do we just give up? Of course not. We get clever. If the hunt for the absolute 100% perfect treasure is impossible, well, maybe we should start hunting for a treasure that's just good enough. And that brings us to the real-world solution, approximation algorithms. These are basically just clever shortcuts. They run super fast in that predictable time, just like our easy quests. Now, they don't promise you the absolute best, most perfect treasure, but they give you something else that's incredibly valuable, a guarantee, a promise that your good enough answer is within a certain distance of that perfect one. For instance, let's say your quest is to place the fewest guards possible to watch every single path on the island. Trying every combination is impossible, but here's a shortcut. Find any path that isn't being watched and just stick a guard at both ends. Then just repeat that until every path is covered. It's lightning fast and it comes with a guarantee. You will never, ever use more than twice the absolute perfect number of guards. And for most real-world problems, that's amazing. And all of this, it all leads us to the single biggest, most profound unanswered question in all of computer science. It's called the P versus NP problem. Are these hard quests on the foggy island truly fundamentally different and harder than the easy quests with a map? Or have we just not been clever enough to find the secret map that might be out there waiting for us? Because think about it, if it turns out that P does equal NP, it would mean a secret, fast map actually exists for one of those master quests. And if we find it, we can solve all of them. Designing new medicines, breaking any code, predicting financial markets, all these things we see as impossible would suddenly become easy. It would change everything about our world overnight. So I'll leave you with this question. What do you think would be the very first thing to change or to break if that secret map was finally discovered?